Come on up. Delighted to introduce our next keynote speaker, Frédéric Barbaresco. He's the Quantum Algorithms and Computing Segment Leader at Thales. I've actually seen some of his presentations, so I'm excited to see the update on it. He's going to be talking about advancing quantum computing, Thales leadership in benchmarking, optimization, and simulation for aerospace and industry. So welcome, Federico.
Okay, just for introduce myself. So I am the segment leader for quantum algorithm and computing. So Thales has been in United Arab Emirates for over 45 years with more than 500 employees providing a solution in defense and security. And we have many collaborations. I could give some example of Sky, Sorbonne, Abu Dhabi, where we have a Thales share. And also recent acquisition of UAE-based startup Astrad UTM, which is working on UAV traffic management. So in Thales, we have a world quantum computing ecosystem. So you have more than 7 countries where we are developing skills on quantum algorithms. So in Europe, with in France, in Paris-Saclay campus, on our Cortex lab in Paris, but also in London, in Germany, and also we have 2 units, Thales Alenia Space in France and Thales Alenia Space in Italy, working on quantum algorithm. And we are also in Canada, in Quebec and Montreal, for Cortex Lab Canada, and also in Singapore. And so we are studying and maturing more than 20 use cases for our global business unit. And we have already 14 scientific publications on this result. So our the main advantage we are looking for is first to address complex problems non-tractable in human time with supercomputer. So I will give you the example of mission planning of constellation of satellite, for instance. So it will give us new operational capability and services that are not available for the time being. The second topic is to accelerate existing algorithms. One example is electromagnetic simulation. So we are using HPC from CEA for the design on the simulation of the radar of RBE2 radar of Rafale fighter, for instance, on Isradome, and also the Grandmaster 200 and 400. So it's a very intensive simulation using HPC, and we want to accelerate this simulation to improve the design of this electromagnetic equipment. And the last one is about energy consumptions, and we are convinced that also we could reduce the energy consumption and the carbon footprint impact of this high-power simulation. So in Thales, we have defined 2 pillars. On the left, you have the pillar for quantum algorithm for engineering, because we are convinced that it will be easier to deploy for our application. So we are constrained on the performances and integrity and accuracy of the computation, because we will spend a lot of money to develop equipment based on simulation. So we have to be sure that they are accurate enough. So it concerns electromagnetic simulation, the design and optimization of our electromagnetic antenna and modes, the performance assessment of our complex system. We have some complex system where we need few months of simulation for a few seconds of scenario, and also massive testing for BACQ. On the right, you have online operations. So we want to deploy on platform. It could be on frigate or aircraft carrier, some application, but also for other ground-based application. So we have mission planning, massive IMINT and LINT processing, complex, very big complex system reconfiguration in case of failure of change of mission, anomaly detection at scale, and resource allocation. But what is very important is also quantum code analysis and verifications. We have the same action for AI, where we are working for the French program Confiance.ai for trustworthiness AI. And so we want also to qualify and validate quantum algorithm. So this is a classical picture of the stack of quantum computing. You have some small vignette of Thales where we are trying to positioning. So we want to develop new algorithms for the time being, especially for fault-tolerant quantum computing. You have very few algorithms. So we want to develop new algorithms. We want to work also on hybrid computing partitioner, to hybrid HPC, and to use quantum computer as accelerators of this computation. Also on the quantum compiler, but the hardware agnostic part, and also for quantum gates optimizer. And obviously, to have a secure cloud access, because our application in terms of security need a very high level of cyber security. So we are working on the algorithmic bricks. Especially, we try to characterize physical gates and the logical gates, on the impact of the noise on the performances of the algorithms. We also address compilation issues, and for algorithm bricks, we are addressing NISQ, noisy intermediate scale quantum, and FTQC, fault-tolerant quantum computer. We have identified different use cases. This is some example. For example, for optimization, we are working on mission planning for remote carrier, but also for satellite constellation. The design of our radar waveforms, the multi-constraint 3D trajectories for drones, the radar antenna and tube design. We are also exploring Monte Carlo quantum algorithm for air defense scenario performance evaluation, massive testing for FMS BACQ. FMS is a system for avionics. And for machine learning, we are exploring anomaly detection for side channel attack, and also method to reduce the data processing for the huge amount of data coming from your new generation satellites of observation. For cryptography, so we work with, especially with Alice and Bob, to try to trust our post-quantum crypto. So Thales has two algorithms which has been qualified by NIST in US on post-quantum crypto, and we try to friendly attack our post-quantum code to be sure that they are safe from a quantum computer attack. On differential equation is mainly electromagnetic simulation for radar and also for communication antenna, but we work also on electromagnetic tube, which are using not only Maxwell equation, but Maxwell-Vlasov equation. So we have also electron transport, and we have to make this kind of simulation to optimize the design of the equipment. And for physics, quantum physics simulation, we address ammunition propulsion. We have to design new powder for the propulsion and explosion of this ammunition. We are addressing also a new generation of quantum algorithm, mixing quantum algorithm and AI algorithms, so especially on three pillars. The first one is quantum gene. So gene means geometric informed neural network. So if you are familiar with this technology, is an equivariant neural network, where we try to, by design, make the neural network robust to geometric transformation. And this technique uses what is called quantum group convolution. And we can find a better implementation with a quantum computer. And quantum pin for physics-informed neural network, to also improve the accuracy of our simulation, and especially electronic simulation, where you have here different examples for Ground Alert 5000, the Ground Master 2000, and also RBE2 radar for Rafale fighter. And quantum reinforcement learning for our problem of satellite constellation mission planning. So we have organized in 2023 the biggest corporate quantum hackathon in parallel in 5 countries. So in Canada, in France, in Germany, in UK, and in Singapore. So I would like to give many thanks to Alexandre Krajenbrick and Elvira Chichenina which are organized with Lab Quantic, help us to organize this hackathon, and we have addressed these 10 use cases, so SAR image segmentation, entanglement routing in a QNet, anomaly detection in an acoustic time series, surveillance drone mission planning, combinatorial optimization shift refit, cybersecurity with such channel attack, FPGA design for optimal placement on FPGA routing, in Singapore, path planning for drone, for UAV traffic management, and radar SAR waveform design. So some of these use cases are now funded by the corporate, and we are maturing this use case. On the winners, so Thales Germany and Thales Singapore, we give the award with Patrice Ken at the Paris Air Show. So I will just give you very concrete examples. So we are working with École Polytechnique in Paris on radar antenna simulation. So we try to explore HHL algorithm. So HHL is a basic algorithm for linear system solving, and we want to couple this HHL quantum algorithm with some technique of optimization for the mesh, and we try to refine the mesh of our simulation to improve the accuracy. Second example is radar target tracking. So tracking is an algorithm which is in all our sensor and system. So we have to track some objects, and we have made some first tests to improve and to accelerate again the new threat. So it will be drones, hypersonic and hypermaneuvering missile. We have to improve the performance of this technology, and we have first a very interesting result because we have accelerate, or especially our MHT algorithm, which is multi-hypothesis tracker, but a ratio which is confidential. But we have accelerate with existing quantum computer, the classical technique of multi-hypothesis tracking, and we are also exploring with Candela the quantum Monte Carlo filter. We have also win 2 contracts with the European Space Agency. So the first one is QC4EO, so quantum computing for Earth observation, and with a consortium led by Rulich in Germany, with IQM, and also with Thales Alenia Space France and Thales Alenia Space Italy, and INFN in Italy. And we have defined for the European Space Agency 4 use cases. The first one, mission planning of satellites. The second one, multi-view matching. The third one, optical image segmentation. And the last one on synthetic aperture radar data processing. And we have won a second contract with the European Space Agency, which is called QR4EO, so quantum running for exploratory research. And the objective is to test on real quantum computer. And the first use case is mission planning of constellation of satellites with Pascal. So we have initiated this collaboration with funding by Paris Région. And we continue with the European Space Agency. So we have a first algorithm running on the quantum computer of Pascal, and we try to scale up for the European Space Agency. So the problem is to control, remotely control the attitude and the position of the satellites according to different requests of observation, with and also under constraint of clouds and also the trajectory of the satellite. With Candela, we are working on growth pathfinding. So the objective is to optimize the trajectory of the drone according to different constraints, so the geometry, the wind, and also a no flying zone in urban environment. And we have started to develop also in Singapore some algorithms and some tests. And in United Arab Emirates, we would like to work with Astra UTM to try to mature this use case for deploying at scale UAV traffic management. So why we need quantum computing? Because we know that classical algorithm could not scale up for thousands of drones on optimizing in real time thousands of trajectory of drone for UAV traffic management. And we give this challenge for the Q Innovation Challenge this week. So you have a page on the web page of the conference on this use case. And the last example is cryptanalysis. So we are working with Alice and Bob in Paris, which is a French company developing supra bosonic 4 qubit. And with some experts from Thales 6 in post-quantum crypto, and some experts from INRIA in quantum cryptanalysis. And we try to attack the ASCON code. ASCON is a code for Internet of Things, labelized by NIST. And we try to study the sensibility analysis to quantum attack, the resource analysis to try to estimate how many qubits and quantum gates we need to break the ASCON code, and also to start a quantum attack for small scale. So Thales is a leader on quantum computer benchmarking. So the French government gives the lead to Thales for the benchmark actions, which is called BACQ, Benchmark Applicatif des Calculateurs Quantiques, so application-oriented benchmark of quantum computer with CEA, Eviden, Teratech, and CNRS in the more large program, which is called MetricQS, which is led by LNE. So LNE is the equivalent of NIST in France. And we are also French representative at EQCBC, which is a European Quantum Computing Benchmarking Coordination Committee with 3 pillars, so France, Germany, and Netherlands. We are preparing the benchmark at European level. For European Space Agency, as I explained, we are working on QC4EO and QR4EO for application, quantum algorithm application for space. And also another maturing market, what is important is which business segments are mature to study the deployment of this technology. And the second one is air traffic management. So CESAR is a very large program on air traffic management. And they launch a call for application for investigate quantum computing applied to air traffic management. And we will work with Pascal on ENAC, École Nationale d'Aviation Civile, TU Delft in Netherlands, and Fraunhofer in Germany on this use case. We are also involved in NATO roadmap. There is a working group, SET-IST-339, investigation of military application of quantum computing, where we are involved and in charge of benchmark. And the last one is the support of the French MOD DGA Proxima program. So we are not directly involved in the program, but we are collaborating with the 5 startups, Pascal, Candela, Alice and Bob, Cobley, and C12, which are involved in this Proxima program. And we try to promote a BACQ benchmark for this program. So we are collaborating with the 5 startups in France. So Alice and Bob working on superconducting circuit. So we are working with them on electromagnetic simulation and cryptanalysis. Pascal with trapped neutral atom technology. We work on constellation satellite mission planning, and also recently on communication network routing algorithm. With Candela, with their photonic technology, we are working on pathfinding of drone for UAV traffic management, and started to work on tracker algorithm by quantum Monte Carlo technique. Cobley is a spin-off of CEA. They are using a spin qubit on silicium, and we are involved in a European project together with Cobley, QLSE2, funded by Horizon Europe, and the objective is to develop 2 demonstrators of spin qubit, one in Grenoble, one in Delft, with 200 spin qubits, and Thales will be in charge of the benchmark. And the last one is C12. They are developing a spin qubit with nanotube of carbon, and we have started to work also on a tracker algorithm. And so here you have the roadmap of collaboration with the 5 startups. About the benchmark, just a focus on the BACQ program. So BACQ on benchmark is involved in the METRIQS program, which is a French national program of metrology for quantum. So you have other action for qubit benchmark, but here BACQ is on quantum computer benchmark. So we have Eviden Atos as partner, CEA, CNRS, and we address 4 problems: simulation of quantum physics, optimization, linear system solving, and prime factorization. And the main characteristic and differentiator is that we have a multi-criteria approach. So we use different KPI, and we aggregate this KPI for the ranking. And we are application-oriented benchmark. So the benchmark is for end users without any skills in quantum. And we have started some benchmark with Eviden, with Q-score max-cut, that we have tested on 5 computers, Pascal, Quandela, IQM, Quantinum, and D-Wave computer. And so we are discussing with Germany and Netherlands to extend the benchmark at the European level. So this benchmark will be a GitHub, where you will find the code to apply this benchmark on your QPU or for your use. You could be also end user and test the benchmark on different QPU. What is the characteristic is that we are multi-criteria because we are mixing, aggregating different KPI that could be the energy consumption, the accuracy, which are fully different. And we are using BACQ, which is a tool of Thales, to aggregate fully transparently the metric and to build a notation, a ranking of the QPU, which is also fully transparent. This is a technology which has been developed by Sorbonne University. So if you are interested, we have a paper on arXiv where we have the description of the methodology of the BACQ project on application-oriented benchmark for quantum computing. And at the European level, with the European Quantum Computing Benchmark Coordination Committee, we are preparing a white paper that should be available soon. So you have first the first page on systematic benchmarking of quantum computer status and recommendation, and it should be available on arXiv next month. Okay, so we organize also a seminar on quantum computer benchmark. We have organized the first one at Paris-Saclay campus in Thales Research and Technology in 2023. And the second one in Reims. So it is an international seminar. I invite you to attend because we invite South Korea, Japan, Singapore, US, Netherlands, Germany to present their benchmark. And the next one will be in Paris, the 24th and 25th of June this year. Thales has also contributed to 2 reports. The first one is GFAS report. So perhaps you don't know GFAS. GFAS is a cluster of industry of aeronautic and space and defense. You know GFAS because they are organizing the Paris Air Show. So it's Boeing, it's Airbus, Thales, MBDA, Safran, Ariane Group, Dassault, which are members of GFAS. And another report from the Académie des Technologies that will be available next month, I think so, on the state-of-the-art of fault-tolerant quantum computer, question and challenge. So sorry, the reports are in French, but I think you have some tools to translate these documents. So this is some recommendation of the GFAS. So GFAS make recommendation to make the synergy with the Proxima French MOD program and to use the existing BACQ project to facilitate access for GFAS manufacturer to quantum machine, to encourage also GFAS manufacturer to adopt and develop the benchmark BACQ for their application, so to try to verticalize for aeronautic and space benchmark. And also to encourage the development of trusted software stack with compiler, libraries, programming software, engineering tools. And also to consolidate and ensure that we are able to guarantee a European industry sector to ultimately guarantee access to machine on a viable economic model for French machine manufacturer. And to conclude, we just would like to make this announcement. So we are organizing the Quest ES conference in December in Paris-Saclay. Quest means Quantum Engineering, Science and Technology for Industry and Services. So the important word is engineering. We are addressing the 4 technologies, so quantum computing, quantum sensors, quantum communication, and enabling technology. It will take place at EDF R&D Paris-Saclay campus. And you could submit your abstract, and you could also sponsor the conference. Here you have the list of the topics that we will address. And we have already the 2 first speakers, so Alain Aspect will opening the conference. And we will have also Pierre Rouchon. I don't know if you know Pierre Rouchon, so Pierre Rouchon has been elected at the French Academy of Science this year, and it is the inventor of a new science, which is quantum control and command, or quantum feedback. And this technology is used by Alice and Bob in France, but also by AWS, Amazon, and Caltech in US. They are using quantum feedback to stabilize bosonic qubit, bosonic 4 qubit for Alice and Bob, but they are also doing bosonic GKP qubit. So the challenge, so for 4 qubit, you can reduce by a factor of 200 the number of physical qubits you need for logical qubit. And the challenge for bosonic GKP qubit is to have 1 physical qubit for 1 logical qubit. So we say that Pierre Rouchon is a quantum computer with quantum feedback for regulating qubit by distributive Lindblad equation, what James Watt was to the steam engine with his Watt regulator. Okay, so without the Watt regulator, we will not have the steam engine on the first industrial revolution. And so the science of quantum feedback and command and control could also revolutionize the quantum technology. So I invite you to attend the conference and to look at the opening by Pierre Rouchon. This is my last slide. So this is a 14 paper published by Thales. So almost all are available on archive or online. So I invite you to look or the different paper on use case we have addressed. And if you have some questions, don't hesitate to contact me for more information. Fine.